Good morning to one and all. My name is Shifa Mohammed Ayaz. I'm a third year electronics student. And today I'm going to teach my eighth experiment. That is application of precision diodes with op amp. So let's get started with the experiment. The tool I'm going to use over here is LT Okay, and so the basic reason why we are using a precision diode is that a basic diode, that is a normal diode, can amplify voltages above zero point 0.7 volts only. It cannot basically amplify signals below zero point 0.7. So here the need of precision diode arises where a precision diode is capable of amplifying AC signals below zero point 0.7 volts also. So that is the basic reason why we are using a precision diode in our circuit. So we will see the basic half wave rectifier, then we modified a version of it, and then the full wave rectifier using a precision diode. So and let's see whether giving input below zero point 0.7 will this diode be able to conduct and give us the desired output or not. So first launch your LT spice. This is how your half wave rectifier looks like. Input is fed at the non-inverting terminal. The inverting terminal uh, is being fed back to the output terminal. So a feedback path has been created and a diode is connected in this forward direction and a resistance path has been provided over here. VCC and VEA is provided from this voltage source. So let's run the circuit and check our output. So click on run, then put your V in and put the probe on V out. So change the color of this V out to be okay. So this makes your output more visible. So this is how your V out looks like. So we are going to see that for positive cycle the diode is conducting and for negative half cycle the diode isn't conducting, so we are getting a flat line. So it is being verified that below, even for below 0.7 voltage, the diode is conducting. So this is about the half wave rectifier. I'll show you my document. Yes, so this is the basic half wave rectifier that I've shown you. The for 50 hertz I'm getting the exact same output as shown over here. But as I keep on increasing the frequencies, the cut in, so the actual output which is desired is is that is getting, as we keep on increasing the frequency, the output goes is not so much satisfactory. So at cases like when the frequency is too high, for the other cycles the diode won't be conducting at all. So this particular thing is because of the because of the parameter known as slew rate of the op amp. So since OP07 has a lower slew rate, so the op amp isn't able to conduct at higher frequencies. But if I use op amp with a better slew rate, the output would be much more satisfactory. So that's the reason I this sort of an output for higher frequency. Next part, that is the modified version of the half wave rectifier. Okay, so this is again the basic half wave. I just modified it by adding one diode over here and a resistance over here in feedback. So let's see what difference does it create in the output. Again, the input is below 0.7 for 50 hertz. I'm going to check this. So click on run. So here is my V in and here is my V out. So let me change the color. So here is your output. So since the inverting terminal uh, is being fed with the input source, so the output for positive cycle is not being seen, so it's a flat for the positive cycle. It is conducting for the negative cycles only. Because of this voltage source connected at the inverting terminal. Okay, so the output is inverted, and for 50 hertz also it is working fine. So the output is as expected. So this is how your modified half wave rectifier looks like. So again, now if I show you my document, this is for 50 hertz. It is giving you a better output. But since, as I said, as I increase my frequency, the output won't be as it should be. So that's how the output gets distorted, and it is not as what is expected. So that's change when I keep on increasing the frequency. So let's move up on to the next practical, that is of a full wave rectifier. So okay, here is the full wave rectifier. Uh, in this full wave rectifier, both the diodes would be conducting, but for uh, in each of the half cycles. Like for the positive half cycle, D1 would be conducting, and for the negative half cycle, D2 would be conducting. And again, the input voltage is below 0.7 over here again. So click on run and check the output. So I'll click on V in and V out. So now since I said that the frequency is too large again in this case, that is the reason my output isn't matching uh, with the applied input. So the output, as I said, due to the parameter slew rate, this change is being observed. So if the op amp has a better slew rate, the output would have been much better. So that's the reason when I give high frequency, this sort of an output is being observed. I'll show you my document over here again so that becomes clear. So now see, for 50 hertz, as I said, it would be working fine. So it is conducting for the positive as well as for the negative cycle. Now since, as I said, it's an inverted version, since I'm feeding the input signal at the inverting terminal, the output would be inverted. But since it is conducting in both the cycles, so you will see this pulsating sort of DC output waveform. But the only thing is that the input waveform is inverted, but the output would be conducting for both the two cycles. Okay. So as I said, as the frequency increases, this waveform gets distorted. Now, moving on to the next part, that is the clippers. The clippers is used to clip the voltage below some reference point. So, what types of clipper? Negative and positive clipper. Again, in negative clipper, we have negative clipper with positive V reference, and negative clipper with negative V ref. The same uh, thing is being implied for the positive clipper. So let's see the circuit right now. So just let me close this circuit and open the negative clipper. So this is a negative clipper with positive Vref. Here the Vref is positive. The input is fed to the non-inverting terminal. Inverting terminal is again in feedback with the output terminal, and a diode is connected in this direction. Okay, and yeah, again the input is below 0.7. So let's see the output first and then let you know. So click on V in, V out. Now if you check, the output would be such that the since since the input is fed to the non-inverting terminal, so output is in phase with the input. And secondly, as I said, the Vref applied is 0.25, so only voltages crossing above 0.25 would be passed through this, and below 0.25, all that voltage would be clipped off. That is why we are getting a flat line. So when the voltage is above 0.25, yeah, your output is visible, and below 0.25 the output gets clipped off. So this is how your negative clipper with positive V reference works like. Then I'll show you negative clipper with minus Vref, negative Vref. The only thing is the same circuit is being used, only the Vref has been given the negative sign. So let's see what would be the change in the output. So this is how your V in, V out. So now if you check, okay, so yeah. So now the output would be such that now it is conducting only for voltages which is crossing the minus 0.25 volts. So if my voltage is above minus 0.25, the these you will see it is conducting, diode would be conducting, but below minus 0.25 the output won't be conducting. Matlab, the diode won't be conducting, so this part is going to be clipped off. So that's how the negative clipper works. Now moving on to the positive clipper, again the same uh, circuit is being shown, only the changes that the diode is being reversed in this direction, and I'm applying a positive VREF in this case, and the same circuit looks. Then again I click on V in and the V out. So now again for voltages greater than 0.25, so this is how your waveforms look like. So this blue part is being clipped off right now. Now since the diode is in reverse direction, so here this is the way the output waveforms would look like. Then for your positive clipper with negative VREF minus 0.25, again the same circuit. Let's check the output. Here is your V in and here is your V out. So now you can check that. Okay. So wherever it is going beyond minus 0.25, the diode is conducting. Okay, and that's how you get the output. And for positive cycles, the diode is non-conducting, so we are getting a flat line. So that's the same as I showed you before, similar output. So now that's the thing. Yeah, we are done with this experiment. Thank you.